to 80 mm at point B. Okay, 150 mm at point A, 80 mm at point B, which are situated at 20 meters and 16 meters respectively. Here he mentioned the datum head. At point 1 is 20 meter, at point 2 is 16 meters. With reference, the height of the pipe is 20 meters at the first point, 16 meters at second point. So Z1 equal to 20, Z2 equal to 16 meters, respectively above the datum. The pressure at A is 0.2 Newton per square millimeters or Newton per mm square, and velocity of flow at A is 1.1 meters per second. Then neglecting the losses between A and B, determine the pressure at B. So A to B you have learned and solved the problems regarding horizontal pipe, vertical pipe. One pipe is connected to two different pipes. Okay, so you have studied three varieties. Now this is another type of problem. Here he mentioned the datum height at point 1 and point 2. Then you have to find out the pressure at point B. Okay, then solve it. Come on, do it. 2 minutes time. Okay, shall I solve? Here the pipe diameter of pipe changes gradually from 150 to 80 mm. So at one end is 150, another end is 80 mm. First it situated 20 meters at this point, 16 meters this point. So that is why gradually it is reducing the size. Here the diameter D1 is equal to how much? 150 mm. if you take the bottom line as a base, has a from center of the pipe, here the height is Z. This side the height is Z1. The Z1 is 20 meters. Z2 and diameter 2 is 20 meters. Okay, at point A, Z1 is equal to 20 meters. At point 2, Z2 is equal to 16 meters. Then you should find out the pressure at point B. Pressure head P1 by W is equal to how much? You know pressure how much? 0.2 Newton per mm square. That is in Newton per mm square. We have to convert into Newton per mm square, sorry, meter square. Then 0.2 Newton per mm square, that is multiplied with 10 power 3 multiplied with 10 power 3. Okay, divided by 9810. 98, specific weight of the water is 9810 kg per meter cube. From this you will get pressure head. How much? 20.38. 20.38 meters. Here the velocity at point 1 is how much? 1.1 meters per second. 1.1 meters per second. Then as per continuous equation, a1 v1 equal to a2 v2. From this, if you want to find out the velocity at point 2, v2 is equal to a1 v1 divided by a2. Okay. From this, you will get velocity at point 2. How much? Area pi d square by 4. D is nothing but 150. V1 is 1.1. A2 pi d2 square by 4. Then you will get velocity at point B or at point 2, that is 3.86 meters per second. Meters per second. Same as earlier problem, you have to apply Bernoulli's equation, that is P1 by W, P1 by W plus P2 by W, sorry, V1 square by 2G plus Z1 is equal to, here neglecting the losses, he didn't give the head loss. Okay, P2 by W plus V2 square by 2G plus Z2. From this equation, you know P1 by W, that is 20.38. V1 you know 1.1 meters per second. Okay, G 9.81. Z1 is 20. This is 20. You have to find out the P2 by W. Okay, this thing you have to find out. How do you find out? You know V2, that is 3.86. V2 you know 2 into 9.81 plus Z2. Z2 how much? 16 meters. 16 meters. Okay, then you will get the from this entire portion. Okay, you will write it as a 40.44. 40.44 is equal to P2 by W plus, if you add these two things, you will get 16.76. 16.76. From this you will get P2 by W. P2 by W is equal to 23.68 23.68 meters. Okay, if you want to find out the pressure P2 is equal to G W equal to 9.8, sorry, 9810. If you multiply it with this thing, what you will get in terms of mm square, point, sorry, at point 2 or at section B, the pressure is nothing but 0.232 Newton per mm square. Okay, if you write in terms of meters, you should take P2 by W. If you want to write it as a Newton per mm square, you should convert it into Newton per mm square. Okay, that is multiply with 9810. These are the different types of problems to find out the pressure in the flow of fluids. Okay, in the next class, we will see the discharge. How do you find out the discharge? A to B, you have studied about the pressure and velocity or the pressure difference. These things you have solved. Okay.